All right. So we're recording. All right. So this is the velocity acceleration section that we had looked at earlier in the course. This part is the kinematics. So let's run through this one basically. So it says based on the movement of an object applying in kinematics equation may be always be the most effective way of analyzing object's motion. For example, we're gonna look at a train starting from rest and the train accelerate, all right, uniformly. Once it says uniform acceleration, it means that it's a slope, right? But it's a straight line, a slope going up to where it will start to they start having maybe uniform velocity or something there. So thereby reaching a speed of 45 kilometers per hour in a time of 40 seconds. So it gives you the speed and it gives you the time that the the train accelerate between, right? And then it says the speed is maintained 3 minutes after which the steam valve is closed off. So once it says maintain, it means constant speed, right? And then the steam valve is closed off and the brake apply. Bring the train to rest with uniform deacceleration. All right. If the train travel at a total distance of 3 kilometers, you must determine one, the acceleration, two, the distance covered while accelerating, and the distance covered while deaccelerating, and the time for the entire journey. So let's look at this quickly. Now, so what we really have here is a velocity time graph. Um, so here we have it. So the vehicle start and it accelerates. It was initially at rest. It started to accelerate and it moves up. I hope you're seeing at my cursor. So this is the uniform acceleration part, right? Now, when it reached up here, the steam valve is closed off right up top here, right, at 40 second. So as you tell you right here, so now when they say the speed is maintained, so you know that this part up here is called as uniform velocity or uniform speed at that point. And then now when it reached here, it also a brake was applied and it's going to deaccelerate and stop, right? So all you need to do, you need to recognize when it is accelerating, a slope, when it's uniform, once it says maintain speed, or it may even tell a uniform velocity, you need to draw a straight line. When it says deaccelerating, it means it's moving from some positive value to some negative value in terms of the slowing down, actually. So the body slowing down. And then now it gives you the time, and it says to you 40 seconds. But it told you that this 3 kilometer was the entire journey. It says the train traveled a total of this. So it means the total period. But what thing you know here, the, the area underneath this graph is equal to the distance traveled in this case here. So area underneath graph, this is a triangle. So this is half base. Base is 40 and the height is 12.5, which is this height here. So this section here. So it means that this here you can find the distance travel for that. Also, you can also find the area for this because the area of this is going to be the height versus the length, which is 180 times 12. So you can also find the distance here. So once you have these two distance and you subtract them from the 3000, you convert this to kilometer to meter. You're gonna be 3000, right? And then you subtract it and you will get what is left here. So from what is left here, you can now find the total time that the vehicle tends to come to a rest. I think that's what it asks. So let me just check. So you must cut the distance cover while accelerating, the distance cover while it is deaccelerating, and the time for the entire journey. So it is straightforward right there. So right there, you would have just gone through, does the conversion of 40 kilometers per hour. You remember, it's just 1,000 upon 3,600, right? And of course, you would get 12.5 meters per second. So remember this conversion is very important. You need to remember it. How to convert from kilometers per hour. Don't remember if that's how I set the question that you'll be doing, right? But you must remember this conversion. All right. So you jump over, and this section is the acceleration section. So first you're gonna go and you find the acceleration. So it starts from 0 and its maximum, its final velocity at this point here before when it is accelerating is the difference between this. So it's 12 minus 0, because 0 would have been initial, divided by 40. So this section would have been your accelerated section, and you get your acceleration. After you get your acceleration, right, what else do they want? So that's the acceleration. So clearly, and we know the distance travel here, and you can use the area of rectangle to get the distance travel underneath also. Right? Then it says the distance cover, and you take half base time height. So it's 40 times 12, give you 250 meters. Right? And you get that section. This other section here, as I told you before, all these three sections will add up to give you the total 3,000. Here. So you get the total distance travel is this, which is 3,000 minus the area 1 minus area 2. We're gonna give you area 3. Right? So that's it. So it's because area 1 plus area 2 plus area 3. So this is crucial, right? And so the distance cover is that. And you subtract these areas here from that, and you would get that last section here. Once you get the distance here, you could just use your area formula now, because the area is half base time height, which is half t times 12.5. So from that, you know that the value was what? The total distance it had was what? 500. What was the distance here? Work out 500. So it's 500 for this section here. So it's 500 is equals to half t times 12.5. So you see there, and you transpose your t, you get 80 seconds. So 80 seconds it takes to come to it. So it's been 300 seconds in all total. So you're gonna add the 220, sorry, plus the 80, your 300 seconds, it brings back to this point right here. Right, very crucial. All right, so we're gonna jump from that. So I hope that you remember all of that. Let's go now to projectiles. All right, we looked at projectiles. And some of the things that you need, I'm just going to remind you quickly some of the things you need to remember. All right. For projectiles, listen keenly now. You will start out to have the body, you will start out with some angle to the horizontal. All right. Let me see if I can get one. So it will have an angle theta to the horizontal. If you are here and something hit it, somebody kick it, and it will travel apart across here. One of the things that you need to remember is that the horizontal velocity, which is Vox, will not change for the body until it comes to none at all. It will always be the same. The only thing that changes will be the vertical component of the velocity. So it will have a velocity, it will have an initial velocity. The initial velocity will have components both in the vertical plane and in the horizontal plane. But the one in the horizontal plane, in this case is Vox, will not change. Only the one in the vertical will be changing as it moves along this part here. So if you look, it starts out with Vox. These are the 0, but initially it have, let's say it have this one. So its X component, the Vx, will not change right along. If you look, see it here, don't change, don't change, don't change, right? But this one here, this vertical one, it is changing as it moves along. When it reaches right up at the extreme top, remember it becomes 0 instantaneously. And then it starts to deaccelerate, come to the ground. So this component, see it here now, see it here coming down. So when it hit the ground is when it will finally come to it. And it has a minus Vy. So you see its component is changing as it moves along. But the Vox, see it here, the same thing that it started out here, it is the same thing that it end up over here. Now, the distance between where it starts and where it hit the ground is the range. Right? So when you ask for the range, you're using the component of the Vox component is what you help you to get the range. So the range is just going to be the distance cover. Right? So the range is going to be typical. We're going to look at that. The height is one of the things that you need to know how to calculate. Maximum height reach is when the maximum velocity at this point up here is going to be 0, right? So you need to be cognizant of that. So let me just jump to a question quickly where we had worked that one. All right. So, all right. Remember this one here? We says calculate this one question here. What is it? It says it at an initial velocity of 28 meters per second, right? And it shoot out here and it travel a projectile path. Its initial velocity, which it was launched, it was 28, and the angle is 30 degrees to the horizontal. So let's look at it quickly. What we're saying here is that the vertical component here is going to be Vy 28 sine 30, right? That is because it forms a right angle. You assume that it forms a right angle triangle right there. Just remember that, right? And so you have your vertical component and you have your horizontal component. This component here, which is 20 cos 30, will not change through the entire frame of the problem, right? From here down to the end, it will remain the same. Remember this component here. So it starts up here so at 28 cos 30. It will end up down here at 28 cos 30, right? But however, the vertical component, this guy will change. It is actually 0 right here. When it reach up here, for sure we know when it reach right up here, so Vy is 0. But Vx remain the same right throughout its motion. So that's one of the things that is critical. So it says initially, so you must calculate the horizontal component, which is the one that never changes. So it's going to be 28 cos, and most time it is cos. Whatever angle you see there, your cos of it, time the initial, and you'll get the initial horizontal velocity. Don't change. All right. It says after you must calculate it says initially horizontal component, right? And then 2 after 10 seconds and after 2 seconds. It will not change after these periods. It will remain the same. Right? That's what we are saying here. So when it is 1 second, when it is 2 seconds, when it's 3 seconds, when it's 4 seconds, coming right down to where it stops. Right? It's when it comes to rest that everything becomes 0 here. It will not change throughout the motion though. All right, so let's jump on and move on. What about this one here? It says calculate the vertical component of the ball. So the vertical component, as we said before, Vy, right? And you can ask questions as we go along, recapping. Vy, please stop me if anything you don't remember. So Vy going along this part here. All of it is Vy going up. And not even drawing Vx. Vy coming all the way up. Up. It's changing all the way coming up. When it reach up here, so it is 0 for sure. The Vx don't change all along the part. It remain the same, but him going around. Him going along. When it reach over around here, so now the Vx will be this way, but the Vy will be coming down. So the Vy start to come down. But that one is changing as it moves along. This one don't change. This one, the horizontal one, don't change. So it remains the one that we calculate before right to the end. 24.25 right to the end. Only one that is changing is the vertical component alone. So this one is going to be your Vy component, initial velocity. So it says calculate the vertical component of the velocity of the ball. So the vertical component is that. Now after 10 seconds, it will change. So it's Vy, you use your standard formula. You remember V equals to U plus AT. Now this one, we must remember that it's acting along against G, acceleration due to gravity. So this is what you're going to work with for your acceleration, right? For vertical component. No other acceleration you're going to work with. And then your time, they give you the time. So you just simply put it here that your Vy component, remember that this is initial. So this is your initial Vy. So your Vy initial is that one, which is, yeah. So this is one that it have initially. Now, this is the one. So when you add this to it, you're going to get a different one. This is minus 9.81. So it's because it's moving against gravity. When you're going up, you're going against gravity. When it is coming down, it's going to be positive coming down. Right? So when it's coming over this way, the G is going to be positive over this side. But it is negative between here, this section right along here, before you reach up to this section here. Why? Because up this section, the body is going up and it is moving against gravity. Here, the body is moving with gravity. So this one is a positive G, while this one is a negative G going up. Any question there? So this is why they have minus 9.8 here on the time. Any question there? Everybody clear with that? Yes or no? You are sleeping or you're not talking to me?
Yes, sir.
Yes, sir. I should think so.
Yes, so you remember that it is positive, it is negative going up there. So let's jump over. What would it be? 2. If it was 2, it would have been the same. It would have been 14 plus minus 9.81 times 2, right? Whatever that value would have worked out to be. Probably, but you have a calculator out. Let me grab my calculator. I'm almost certain not to put it out. Here's your calculator, guys. What is that value? I'm almost certain not to put my calculator out. 1 second, let me just. What is that value? Have you worked out? I'm looking for my calculator. Oh, here it is. All right. Okay. What is that value? You guys come like you want to sleep. You're not into talking tonight at all. All right. So that gives you so you would have actually get a negative value there. Let's
Negative 5.62.
hold on. Let me see if I can get my writer function in it. Where is it? So it is 14 minus 19 point what? 9.62. And you get how much you get? Negative what? 5.
Sir, no, sir. Hold on.
What?
Hold on. No, not you. It's something wrong with my calculation. I think I might have added it instead of
You remember I told you that it's acting against gravity, so you must make it be minus. Remember? That's why. So you'd have that to be. So in other words, when it is 2, it is actually over here. When it is 2, when it is 2, let me just. When it is 2, the body would have been over the other side coming down. That's what it is telling me, right? The ones that it says minus, right? So it would if it is plus coming this plus will be up to 0 up to this point where it initially becomes where it's instantaneous becomes 0. The first half of the motion, the curve motion. Remember, some of them are symmetrical. All right, remember that. So the first part, let's assume it is symmetrical. The first part is gonna be positive velocities. After it passes the top, the extreme top, you're gonna assume that it is negative velocity coming down there. It could be negative velocity, right? Depends on the time and so forth. So in this case, you see that it is minus if you put 2 in it. All right. Let's jump back over. It says calculate the vertical component of the velocity of the ball after 2 seconds. So you see, we had calculated what we got here, minus 2, and they gave us, so they said, let's see how far the ball for 2 seconds. The time for the ball to reach its maximum height can be found. So they said v is equal to u plus 18. Know that at maximum height, the vertical component is 0. So we told you that already. So if you put 0 here, we know what the height. So they're actually calculating it right here. So that what they've done here is calculating the time for it to come here. The time is 1.43 because 0 is equals to 14 plus minus 9.9. And so this is be your maximum velocity, 0, right? Because right up here, see it here, Vy is equals to 0 meters per second at the extreme top. Everybody see where I'm pointing up here? So it is extreme top. So I see it right here.
yes,
And
sir.
the 14, this is the initial velocity. See it here? This is equal to the 14. That is the initial velocity up here. So that is the Uy initial. Uy initial is 14, but at t equals to, so we don't know t, they were calculating what it is at maximum height. So see there, we are able to get at maximum height, the time is, for it to reach out to maximum height is 1.43. Now, this distance here, what did they say now? They say you must calculate and see when it is 2. So it's 2, the distance between 1.43 and 2 is apparently somewhere over here. All right. So what they do here, so it says after 2, at 2, the ball is at this point, right? It is between the 0 with the maximum height. When it reaches maximum height, it is at this little distance here, up to 2, right? So up to 2 is right here. So that's the difference between it. Now, so there are many ways you could approach this problem, right? So what we certainly know is that when it at maximum height, right, the initial velocity, your initial velocity, so when it reach up here, so this becomes your initial velocity coming down. So it's like its motion start over when it stop here and moving off again. Remember that. So when it reach maximum height and you're looking for anything over this side, it's like you're starting over. So this becomes initial. It changed from the final velocity for this section. So when this is initial velocity over here, which is 14. Remember that. This is final now for this section. Vy is that. But this is for this section. When it reach around this side now, it's different. This is now this final velocity become initial velocity for the second section, and then it will have a final velocity whatever down here. But it says initial velocity for this section of the motion is different, right? So it's at 2 Vy. You want to calculate it. So this is the initial velocity at the second for the second stage here, coming down to here. And look, notice that this is positive 9.81 because it is a positive, it is coming down with gravity now. It is not acting against gravity, it is positive coming with gravity. So it's 9.81 times the time, right? So that is one way of doing it. So it is 5.59. So that's one way of doing it. All right. All right. So all right. So that's one way of doing it. Right. Now the
Sir, so they calculate the vertical component of the velocity
mm-hmm.
of the ball. That a part A, right? The initial velocity.
Come
The
again.
initial
Let me
thing.
see if I get it.
So B is different from down here where so therefore at T 2.0 seconds, the ball is 0.57 seconds into the downward. So you're saying when it's coming, the first part of when it's coming, it's before it reaches zero in the middle at the top, right?
Mm-hmm. At the
That's
maximum height.
negative.
Maximum height. That
That's right.
maximum vertical height.
Maximum vertical height.
Mm-hmm.
It's a negative, but when it's coming down, after it reach zero and it's
Mm-hmm.
going down with gravity, it's going to be a positive, right?
Well, we are saying the velocity tend to be positive coming down. Yeah, depends, depends. So I'm not the negative positive thing. What I'm trying to tell you, what I
Mm-hmm.
will tell you is the acceleration value. So you use it minus when you're going up when it's going against gravity. When it's
Okay.
coming down from the maximum height, that's one thing I'll guide you and tell you. When it reach maximum height and you're coming down with gravity, you must take that G as positive because it's acting with gravity.
Okay.
It's like the astronaut falling out of the sky and them coming down. They don't have a negative G affecting them. They only have a positive G propelling them to the earth, actually pushing them faster down to the earth than anything else. You understand what I'm saying? You remember, there's a resistance, going up. So you're resisting because the air, you're moving against the air resistance going up. So that's why we consider it a negative value going up. And depends on all your convention. So we are using the convention when you're going up, just like when we're doing reactions at for the beam, for the frameworks. We consider up as minus. Wasn't that what we did? I'm trying to remember how it go. Yeah, no, how did we do it? We say up is positive. I'm trying to remember the convention. What did we say? When we say up is positive in the that is kind of different. I don't want to confuse. What we're actually saying here is the acceleration. Let me separate both of them. So let me draw it over here. When you're coming, you have the motion here. When you're going up to the maximum, we are saying you use negative G. When it move from here, come down here, we are saying you use positive G. That's all I'm saying. You get me? And this
Okay,
distance
understood.
here is known as your range. This range, one thing you can know about your range value here, your Vx, is gonna be equals to the distance times time. This time, the distance you have here, the range. Let me get rid of that again. So so velocity is distance and time. So one thing you know about your range here, this is your range. That distance along you we call that range. Up here we call it maximum height, h. Right? So let's look at it quickly before we continue on. So see, we see that we had calculated our velocity around here. What is it? 5.6 we get, and so roughly same 5 point something they get around here. So see it here? Same thing basically. And that is at when time is what? 2? Yeah. So we had to actually increase it to time is 2, right? So we got minus but I'm just telling you in terms of the direction where it is. That just showing you the sign. All right, let us continue. Where are we now? It says, at what time will the ball reach maximum height? Now, we know we had calculated this before a while ago. See it here? When we right here, we had recognized from this expression here that when it is at maximum height, your final velocity up here is 0. So you use your basic standard formula. This is your one of your standard form. You need to remember that velocity, the final velocity is equal to initial velocity plus acceleration time time. This is one of your very basic formula that you need to remember. All right. So you just put v is equals to 0. See it up there, top of the graph. And your initial one that you started out with vy. So remember, though these velocity that we are talking about now are all the y's. Y component, not x. So there are Vy. So the Vy up here, listen to me, this thing is 2D. It's two-dimensional, right? It's not one-dimensional. So you have your X and Y axis. All right. So your Y component of your velocity is Vy. And the initial, so the final one is Vy, while the initial one is Uy. Right? And so this is the final, this is the initial. And then you put in your value acceleration, you get time. So you get the time right when you come here. That's why you get 1.43 for just coming between this point right here. So that's the time it covers right here, right? For it to reach maximum height. And this is when it instantaneously stops. So it momentarily stop up in the air, up at the extreme top. Where are we again? So it says, what time will it? So we already calculated it. So it's right here, right? Now we move on and say, what is the maximum height achieved by the ball? So we want this here, that big H. That big H, you're going to apply the next equation of motion. So you have Vy square is equal to Uy square plus 2AS. You remember that one? You need to remember it. You'll get it you'll get it on the formula sheet tomorrow anyhow. You just need to know how to use it. So it's V square equal to U square plus 2AX. Now, so look how it's applied here. So this is the velocity at
Sir,
maximum height. Go ahead.
sir, what's this? What's this equation called again?
This is one of the equation of motion. So look, you had one around here a while ago. Switch one. So the first one you need to remember, this is one of them. This is what standard one. You have to make sure you remember that one. But it's on the sheet. But you just need to know how to use it. You will get them now. I give them on the sheet. So you have the formula sheet in the exam. So V initial velocity, final velocity is equal to initial velocity times the acceleration g times t. So that a there is g.
Yeah, man, I have that one.
Right, right. And then now the second equation that you need to remember is that your final velocity square is equal to initial velocity square plus 2AS. You will get that in the exam tomorrow. Once it asks you for this H, this S here is that H you're asking you for. So it means you're going to transpose to that H, which is obviously going to be Vy square minus Uy square upon 2A or 2G. Because this A here is G, right? So you put in G, but the G that you put in there, you know, this is a minus G you put there, right? Because it's traveling up to, we are considering from here to here. So you use a negative G, right? So you get that value. And what happened? You will actually, I think the difference may be this, what you will find here, the difference here will be minus. And then this will be minus. And I'm trying to remember, and I think it cancels. So it will give you a positive value. And that's how it works out. So this will be minus. With it, this is 0. So this will become over as minus. What is it? Minus 14. So minus 14 divided by minus 19.6 will give you is that so? I think it's something to that effect. Oh, but this is square, sorry. So that this is square, but this value is going to be minus. So when you square it and bring it over, it will be a minus value. Right. So that's how it works out. So you square the 14, but you square it before you bring it over, and then it will be automatically you're subtracting it from 0, so it will be minus, and the minus cancel minus, so you get approximately 10 there. All right, so that's just remember that. All right. So we go over now, and it says, what is the acceleration of the ball at its maximum height? Who want to tell me what's the acceleration there? at maximum height and it doesn't have a velocity, what is acceleration there? If I tell you that it momentarily stop up there, what is the acceleration?
Zero.
Exactly. Thank you, sir. F now, it says, at what point in the flight will the ball experience minimum speed? Where will it experience minimum speed?
Sir,
So
at starting,
at the start.
Um, what did you say, Aisha?
at the starting.
No, at the starting it is 14.
Oh, because
This is where
when
that value will come 14.
gravity is
I don't
actually
remember
pulling
what
it
was this
down,
value. Somebody
so
can figure that out. But this is 14. This the value don't change. The Vx component we just have here will be same Vx component down here. So whatever you work out down here is the same thing down here, right? But the maximum height, so up here, so this is minimum speed, 0. That is when it experiences minimum 0 at maximum height.
because
That's all
it's
we're saying.
stopping. Okay, understood,
All right,
understood.
good. So let's jump back to, so that's the same question I have on the paper. It was actually worked out here already. So I think it's the same value. Okay, what is the minimum speed during the it flight? So we answered that already. Didn't we answer that? And we say what is the time does the minimum speed occur? So these are questions. All right. Says at what time after being launched will the ball return to the ground? Right. Now, the flight of the ball is, in this case, it is symmetrical. So we're saying it is whatever here, first half here, between this distance here, is the same thing happening over here. So it's symmetrical. Just like when we tell you that in the center, the problem is symmetrical about the center, it is symmetrical here. So we are saying here, if you double the maximum time, it was a 1.43. If you double it 1.4, this is also 1.43 to bring it back down to 0 over here. So that's what we're actually saying. So it's double with here. So that is the time of flight. What is the time after which the ball is launched? We return to the ground. So it's it here. That is the time that we return to ground. So the flight of the ball is symmetrical. Downward motion mirrors the upward motion. So you see there, this is upward motion, this is downward motion. So it mirrors it. Therefore, the time to reach the ground after it launch is just double the time. So whatever. So this is the time of flight. 1.43 is the time of flight, but the time to reach the ground from where it is launched over here is double the time of flight. So I say the time to reach maximum height is 1.43, and you call that time of flight. So they are different. Time to launch to come to the ground is different from time of flight. So I just want to make sure we clarify that. It's not the same. All right. So it's double. In this one, it is symmetrical. You may get a problem that it is symmetrical also. All right. So what else do we ask for? What is the velocity of the ball as it strikes the ground? Now, it has an initial velocity, which it has a Vx, which never change. You remember? It never changed. And a Vy that was continuously changing. One of the things you must remember. What is the velocity of the ball as it strikes the ground? So when it reach over here, it will have, this value will not be changing. Will be same 28 cos 30. What was that work out to? What is that value? 28 times cos 30. So that value was 24. I think it was what? 24 something, 24.25 or something like that meters per second, and that is Vx, right? And it's the same value it have right here. Now, when it strike the ground, they say it will, so you have to work out this other. It says the ball will strike the ground when Vy equals, so it equals to 28, right? Now, the angle here is still going to be 30, all right? So they're only showing you that it will have a component. So when it reach over here, it will have a component V, see it here down here, Vx, and it will have a component coming down, right? And you can simply work them out. So the Vy, we had to work out a Vy. See it down here? It says, what is the velocity of the ball as it strikes the ground? The horizontal component of the ball remain constant. So Vx is that. So that is the formula. This is the second formula, equation of motion. V squared equal to U squared plus 2AS. And so you just simply input that at so the initial velocity up here, look, up here this is going to become your UI, right? So your UI is here, see it here, 0, and then it's going to be coming down down here. So you have to calculate the final one now is going to be 0 plus 2 times 9.81 times 10. So the Vy before it strike the ground down here is going to be 14. So please remember that. Look, so it's Vy square is equal to Uy square. How do you get that 0 here? So remember, this here is where it is changing for the second part of the motion. This is 0. So this becomes your initial velocity. The final velocity for the first section becomes the initial velocity for the second. You remember that? So this was Vy equal to 0 up to here. When it for the second motion now, you can say that now moving off, this is your initial velocity. And therefore, you'll have a final velocity down here that is now equal to 14 meters per second. Who understand that? So initially, you have 14 here. Final velocity is 0 here. But for this case now, for the second one, this becomes initial velocity now, and this becomes final. So then switch around. You notice that what is happening there? So Vy equals to that. So simply you put it in here, you get 14. So that means if you do the same thing here, so your V here, how did they get 28? It says V0 is going to be equals to the 24.25 square plus the 14 square. And you root that, you must get 28. Right? So that's how you get the 28. Please remember that. Very, very important, because the time of flight for the ball is symmetrical to Vy, right? So that is 28, and you can, and if it asks you at what angle it hit the ground with, is just Pythagoras theorem. So you have Vx and you have Vy coming down. So this is 28, right? While Vy component is here, which is, so this is 28, this is 14, right? But so, and this is 24.25. So all you need, once you divide Vy, which is what? Vy is 14 divided by the 24, that you use your tan, and your tan will give you your 30. So you get back the same angle. So the initial angle is the same angle, same 30. Once it's symmetrical, it's the same angle, it will hit back the ground. All right. So I hope that, please go back to it, make sure you understand this. It says calculate, now the last piece, which is very important. Calculate the horizontal range of the ball. Remember, I tell you that range has to do with the horizontal. So what velocity we say about? So the distance is going to be equal to velocity times time. Yeah, that's what I wrote before. I hope that's what I wrote. I probably in erroneously wrote the formula wrong. But this is a range. So your range is equal to your Vx value times your total time to do it. Remember that the total time, we had double the 1.43 for halfway. So it's 1.43 halfway, and the next 1.43. So it's 2.86 is this time. 2.86 times the Vx, which was 24.2 something, because it was what? See it here? See the value here for it there? It never changes. So your range is just going to be your Ux times your time to reach the ground, strike the ground. That's your total time to strike the ground, right? So in this case, you just put in whatever angle you get there. This is going to be your Ux, and you work out this. One of the things you need to remember to work out this guy is just to remember your time of flight. Time of flight is reach maximum height, where your final velocity is always going to be 0, right? So is that clear? Anybody have any question there? So this is how you calculate your range. So you need to remember, don't words, range, remember, when a man go to range, him shoot straight and horizontal, most time. So you consider him shooting straight at the range. Just use something to remember the term, so you don't mix them up. Well, so the maximum height is vertical, range is horizontal. All right. Any question? Because I'm gonna leave that now. So you were getting something similar to this, so please know it. And that's the only thing I can say to you. All right, I'm out of that one now. Let's go to the next one. All right, let's go to our Zoom and all. All right, so that is this question. Well, the value is different here. Who want to tell me how to work this one? It's the same thing that we did a while ago. What's the maximum height here? Who can tell me how to work the maximum height here? How do you work the maximum height here? What's your initial Vy velocity? Your Vy velocity, and I want your Vx. Somebody tell me what those values are. See if you're comparing what we did a while ago. What's your your Uy and your Ux? But initial velocity both in the vertical and the horizontal. What's the initial velocity for that?
Sir, is it 10 sine 30 for the vertical component
Yes.
and for the horizontal component 30 10 cos 30.
Yes, that is it.
Sure, we get
Yes.
5 and
So this
8.66.
is 5 meters per second, and this one is 8.66 something. Right. So those are the initial. So it means that it will not change. This is its horizontal velocity, which is your ux, which will not change for the motion, 8.6. But your vertical one will change, which is 5. So your u. So this is your u that it start off with. Your uy is going to be 5 meters per second. All right. What is? Can you tell me how do we find the maximum height now? Somebody tell me how to find the maximum height quickly. How do we find maximum height? What formula can you use to find the maximum? What do we know? We know that your initial velocity Vy is equal to 5 meters per second. What do we know about at maximum height? Your Vy is equal to what? What is Vy at maximum height?
We are equal to 0
0.
at the maximum.
Good. So we know those. All right. So therefore, which formula would you put this in now to get the maximum height right here? This h here that I'm asking for right here. So get this side. And you have g, but remember you're going to use a negative value of g because it's going against gravity. Which formula are you going to use?
We don't remember the formula exactly. You have to look on the formula sheets.
Sir, sir,
You have many formulas. Which formula would you use?
sorry, I use the one u squared plus v squared plus
You want to
2
try u
as.
squared or v squared. Let's check it and see if that's the one, the correct one, if your prognosis is correct. So you're saying you would use v square y equals to u square y plus 2as. That's what you say you would use? You sure? Because you have this one, you have that, and you don't have this.
Yes,
So
sir.
let's see if it goes. So it will be 0 square equals to u squared by what? Your initial vertical velocity is 5 square plus 2 times 9 point minus 9.81 times h or s, whatever you want to call it. If you transpose that, what am I getting here? So you'll be getting 0 minus 25 upon, because this is 5 square, upon minus 19.6 something. How much is that value? 62. Right? So what you will be getting there, you will be getting that this value is equals to what? 1.27 meters. Do you agree with that? Do you agree with
Yes,
that?
yes, sir.
Good.
Yes, sir.
All right. Next part of the problem. It says to you, right, you are to find the total time of flight from A to C. But you cannot find it from A to C straight. You have to find from A to B first. Right? Which automatically will be off of it. So what is it? So let us find from A to B first, and then we will double it and you'll get A to C, right? Because we're considering that, so we can, so it's right. So how do you go ahead and find the time to reach maximum height? We already have maximum height. How do you find the time to go there? We know that V is equals to U plus AT. All right. We know that formula. So that formula can help us because we have time, we have acceleration. We don't have time, sorry. We have acceleration though, but we have these two. Don't we have those two? You agree that we have what is it?
Yeah.
What
Yes,
is
sir.
the final velocity at max at the maximum height? What's the final velocity at maximum height?
Zero. Zero.
Right. So Vy, so see we have it Vy is 0, but U is equals to 5 meters per second. So therefore it means that your T to go halfway, which is given to maximum height, is gonna be equals to 0 minus, all right, let me do it the right way, because if you're not following, it don't make sense. I do the session. So we're just gonna plug it in the formula that we have there. So let's put them in. Aisha, are you hearing me? Or are you going to sleep? So 0 is equals to,
Sir, not sleep.
so Vy is 0, see to her, and this is Vu. So this is 0, the final velocity is 0, the initial one is 5, plus this is minus 9.81 times t, right? So this will give you transpose for t, you automatically will get 0 minus 5 divided by minus 9.81. And how much that will give you, guys? It will give you positive 0.5096. Do you agree with that? Seconds. All right. Now that you get
Yes, sir.
that, all right. Now that you get that, what is the total time of flight? Now that you get that, this is the total time of flight. The total time of flight is double that time. So your time of flight is going to be equals to 2 times that t. So it's going to be 2 times 0.5096, which will give you, I think the value is 1 point something. What's what? Anybody work it out? 1.019 seconds. All right. So that's what your total time of flight would be. All right. Let us clean up the diagram. All right.
Sir, one quick question there, sir.
Mhm.
So at no point in time we are going to take into consideration the 10x, the 10 cos 30 in a no calculation whatsoever. I just the y component alone where I use right through
Yes,
it.
you use it in the range. The
Oh,
range.
so the only time
Range
we
and when you
use,
find in the final velocity for it to hit the ground. Those 2 times when you use it. Let me, oh Lord, I run out of space here. All right. Let me put back the figure here. I'm trying to clean up. I'm gonna put the figure on so we can look at the figure. Or we lose a figure. So that is only time you use it. Well, that's its main. It's main. It come in handy for the range. And remember, the range is the horizontal distance, right? So the horizontal distance is the range. Remember that. All right. All right. So the range. Oh, can you see that? Maybe I can't see it. Let me make it a little bit bigger. All right. So the range. All right. So what else they ask of us now? They ask us for the velocity with which the ball strike the ground. How did we work the velocity with it strike the ground a while ago? The same question, you know. It's the same thing. It's the same thing. How did we work that a while ago? It says the velocity at which the ball strike the ground. What do we remember? We end up using Pythagoras theorem, right? Because we said that this becomes initial velocity for the second stage. This is become initial velocity, and the final velocity is gonna work out back to 5. The Vy. Right? Remember we work it at the final velocity before it strike the ground for the Vy is going to be 5. So I mean the Vy component. So the final velocity that they have, they square them. You remember we did that a while ago? Anybody remember? So we use Pythagoras. So it would have been Vy V resultant. The resultant velocity is going to be the root of what was it again? U uy square plus our final uy square plus vx square. That's Pythagoras, right? So we
Sir,
end up,
which question you answer now?
oh, see it right here. Sorry. See it here? It says the velocity which
Oh,
the ball strike the ground. So it strike the ground over here. Remember, we just look at it. Let me just flip back to the slide if I can find it back. This one here. See it here? This one right here says v is equal to vx plus vy. So you want to find the final velocity which to strike the ground. But I already explained to you that if the body, for the first section of the body, it comes up here, it was 14. This is final velocity up here. So for the first section, the initial velocity vy was 14 up here. So, but when it's cut the second section, this now becomes uy equal to 0,
so
and this becomes
one quick question there, sir.
equals to 14.
One quick question there, because I wonder if a work out that necessary. So if the thing's symmetrical and it wouldn't equal the same velocity where it come out up on the other
Yeah,
side.
All right, it's very
that's what I
important that
was
you
saying.
answer this question. Now, if you're going to exam, your examiner may require you to demonstrate that you work it out and show the understanding. If you write back a value there, you may get 0.
Really,
Oh,
sir?
Yes,
that's crazy.
yes, yes. And I am the examiner. If you give me back the answer without showing the demonstration,
Sir,
so you're
That's
going, no. Let me make sure I tell you from now. So you can pass down to everybody, work out everything. So what is the velocity of the ball before it strike the ground? The horizontal component of the ball remain constant. So you know, so the Vx where it started. In our case around, in that problem that we're doing now, the Vx is 8 point something something. Don't you remember that? So you're going to work out the Vy. You're going to, for the second part now, let's jump back to
sir,
our
go back
slide.
to the slide, please.
This one here. Here,
Yeah, man, the last one we're working on.
this one we're working with. Are you seeing it
Yeah.
now?
Yes, I'm seeing it.
Yeah. So for the second section now, let us work out what is going to be Vy down here. We know it's 5, but I'm going to have to demonstrate. So it says V square y is equals to uy square plus 2as. Now, so your initial velocity here, so that become, for the second stage now, this become initial velocity. So that is 0 square. Your uy, right? So you need to get your uy now. What was your uy here? We had known that it was what? 5, right? That is what we had there. Right? Square, right? What else we wanted? We wanted to say 2 times g. Let's check back. What we're working again. So we're working for the second section. We were working. Oh, okay. So we're working this one when it reach maximum height. Okay. So we're working about the Vy when it reach maximum height. I'm demonstrating that. Okay. Just remind myself what we're working. All right. So let's get back to it. So okay. So here now, so we're saying our final velocity. So we're working out final velocity before it reaches the ground. Okay, that is what we're working. So the same formula. So we're saying right here, this initial velocity is 0. We don't know the Vy that it's going to strike the ground with. So this Vy square, then this square, because this is known. So the Vy down here, we don't know it. We're trying to work it out. And times the S. The S we already work out in our case. What was S do we work out? What was the maximum height? Didn't we work it out? Did we work it out? Did it see it here? 1 point, was this what? It says H was what? 1.27. So it's 1.27. So it would have been Vy square equals to 0 square plus 2 times 9.81 positive times 1.27. What I work out? Anybody can work it out quickly for me? Tell me what you get. So remember, it is square, the V square. Remember, so it's going to be Vy square equals to, that's 0. This is 19 point, This is what? 19.62 times 1.27. And then you take the root. You can drop this square and take the root. What do you get? One value quickly. So you will get in, let me check what value is that, 981, right? So it's 19.62 times 1.27. And right, and you're gonna root, the value that you're gonna get to root is this value here, 24.9174. When you take the root of that, right?
That's 4.99.
Right, so it give you back what? 4.999 is approximately 5 meters per second. So that's what we wanted to demonstrate. So I wanted to make sure. So this is now your final Vy before it hit the ground. So this is a final Vy before it hit the ground. So therefore your V for the overall motion before it hit the ground is going to be 5 square plus what was the V thing that we calculated before? It was what? Calculated right up here.
8.66.
8.666. So you drop that in. 8.66 square. Alright, and what is that now? So you're going to be going so it's going to be 5 square plus 8.66 square, and that gives you V square is equals to root of, so take out this, I'm doubling up right here. It gives you 99.99. When you root that, what you get, guys? You get 9.99, which is approximately what? 10. And that was what you started with. You remember that, guys? Right? So it shows that it hit the ground back with that final velocity there. So you have to demonstrate that. If you give me any 10 there without demonstrating that is 0, for example. All right. Anyway, the last part now it says here, the range are traveling by the ball. The range are traveled by the ball. All right. How did I say it? What is range again? What's the formula for range? Somebody remind me. I'm not showing you. Tell me what is range. What is range formula? The range is what? Horizontal motion. So range is equals to what? Velocity times what?
Time.
What time? Which one of the time?
The overall time, sir.
Overall time. Overall. Right. It's the overall time. And what was our overall time? We had to work it out. See it over here? 1.019. So it is 1.019. And what was what's the Vx? It's a Vx value we want now. What is our Vx value? So it is going to be, in our case, 8.66 times 1.019. What that work out to be? 8.66 times 1.019. So you get,
Sir, we get 8.824.
5. Or you can
Yeah,
round it
25.
off to 8.83, right? Meters.
No, well, okay.
Yeah, you can round it off. You can round it off to the 2 decimal place, 3 singular figure. That's all right. So I won't kill you for that. And that is distant. Remember? Remember, so that was distant?
Yeah.
All right, it's distant I asked for. So that is how you would have done a question like this. So that is a range, big R. So big R is a horizontal distance, while maximum height is a vertical height. And only thing you need to remember that at maximum height, your final velocity for the up there is 0. That is for the first stage of the motion. For the second stage, it becomes initial velocity, which is 0. Those two things are critical to remember. All right, and I am all right. So now we can jump to our. So all right, I'm done with that. Let's quickly run into this question here before we. Any question, because I'm gonna move on. You're all right now?
Sir, just to be sure, you're
Yeah,
going to
man.
post this video again, right?
What?
We just ask if you'll post the video again. Just ask me.
Okay. You tried to post it yesterday, you don't see the one. You don't see it
Yeah,
yesterday?
man, I saw it. I saw it.
Okay, all right. So now you
Wait,
get a
where's the
problem like
video?
this,
It's on
right?
Moodle?
No,
No, it's on YouTube.
you what?
Una na watch sir something. Una na subscribe, you know.
All
Oh,
right.
sorry, you're on YouTube. I forgot to subscribe. No, I'm subscribe,
I
man.
have about 60 video or more here. I've been
Okay.
here for a long time. All right. Anyway, beyond that, yeah, man. Persons have been liking my video around worldwide. All right. Anyway, let's move on. The frame, you have this frame here. All right, guys. If you get a frame, all right, and let's say suppose we ask you to find the member, the force in the members AH, AB, right? And we want you to find for argument's sake also GF, CF, and CD, right? So what you're going to do, the question is you're gonna find it's normally gonna split up into two forms. You're gonna ask for use the joints, method of joint. So the method of joint you're going to use for maybe these two, and it will tell you specifically one you must use for method of section. So method of section is this normal that one. So you're gonna split up. So let's go through it quickly. All right. I didn't pre-work this one out, so we're gonna just have to roll with it. So this is not the free body diagram, this is a space diagram. So you're going to draw your free body diagram. All right, but before you do anything, yeah, you can sketch it back quickly. So let me just make this a little bit smaller. And we're gonna sketch it quickly. I know time is of essence. Come on, tool, where are you now? My tools, okay. Let me go again, see if I get them. All right. Make him a little bit smaller, a little bit too big, taking up the page. All right. Hopefully we can see it still. All right. So that is your figure. All right. All right. We're gonna sketch the drawing quickly. Where are my tools now? Tools, drawing tools. Not seeing any of them. My tools, where are they? They are. Hold on. Hold on. That's out. Text off. Trying to get my tools to be working. Just 1 second. Don't know what's my tool is gone. Oh, it is on text. How does I get it off text? So when it is on text, it's not showing up. All right, I'm trying to get these two to work. Let me see if I go to pen, if they will come back. All right, yeah, they're back. All right, so we're gonna draw some lines first. Yeah, so here they are. I'm looking for them. Yeah, so we're gonna draw a line first. So first thing you do, you draw your quick free body diagram. All right? Oh, it has to start. So you draw your free body diagram quickly, guys. All right? So you just draw them up. All right, we do it quick as possible to may not look exact like the one up there, because I'm just doing this a quick one. All right, and then you will have one somewhere here, like that. All right. I'm actually using my mouse, not even using my pen. Just the interest of time. So you sketch it back. So your free body diagram, right? Guys, I'm doing my best trying to just sketch it. So you sketch it back.
Sir, this one good man.
All right, cool. And then now, all right, you are going to put in your arrows. Now, I notice a lot of people drawing free body diagram and they don't know how to draw a free body diagram. That is a big thing about it, and I'm so disappointed. I do it so often and I do understand. How come you don't understand it? So one coming down here, right? And one coming down here. So you must put in this. This is known as your free body diagram. And then you quickly Let's go to writing now. Are you going to label them quickly? A, this is B, C, D, E, F, G. You not to draw, you just to sketch it here. So you don't spend the whole day doing it. All right. Now, when you finish that, you must look now. The next thing you're going to look at, you're going to finish label. So this is, you can call that AY, and you can call this EY, because they're going up. This is, you put them in 5 kilo. We have to try and make sure not to leave out anything because the problem won't work out. And then now, you're going to look in your geometry. Your geometry is going to be another challenge, guys. Look, this is 4. So it means right across here. Can I use a colored thing? Right across, this is 4. That vertical height there is 4. This distance here is 2. Right? Now that you know that this distance is 2 between this, no, 4, sorry. And this one is also 4. There are 4. So you know that. So what that tells you is that you have some right angle triangles that you can work with. So right here, say if this is 4, right? But this is what? The total height for this one going across here is 6. This is 2 and this is 4 down here. So all right, you see, if you know this, guys, you know that if you have a right angle triangle and this is 4 and this is 4, then this is what? What angle is that? A 45. Not true. Right? Once the angles are, the lengths are equal, it's a 45 angle. All right, so this is, so we know it's 45. So we work with that. So if both of them, that is 45. It means that this line up here, so 2, and by right angle, this angle up here, so 2 is 45. To the horizontal here now. Not anywhere beyond. This little distance here is 45. That little angle here. All right. And it means if it's symmetrical, this is same distance, this is 45 also.
Sir, you're sure that little angle up is 45?
Let us check it now. No, let us check it. I don't think it's, yeah, you're right, maybe not 45. Sorry. Let me just check it. Let's just check it. No, it's not 45.
I don't like
Not
angle
45.
underneath it would be 45.
40. It's not 45. This is 4 and this is 2, so it's not 45. So that is a different one. Sorry, trying to go fast. Yeah. Let's go. Let's check it. So this one here is 4. This is 2. So that means that alpha there, whatever you want to call it. So tan alpha is going to be 2 upon 4. And what that work out to be is tan of 0.5. Tan inverse of 0.5. So inverse tan of 0.5 is 26 point, what's that? So alpha here is 26.57 approximate. Yeah, right. So it's not right. So good. So right. So you, okay. So those are the dimensions. So you make sure you work out those. All right. Once you finish those, guys, we can start working the problem. You must check your angles them. You must understand the geometry of your frame. You cannot work it without you understanding that. And that was a very good call, sir. Thank you, sir. It means that you're observing. Very good. Thank you. All right. So now the first thing, it is always advisable, not always. You could take moments straight, guys. All right. So you can either you can use your equilibrium equations now. What are your equilibrium equations that you are given? You know that the sum of your forces in your x is equal to 0. Sum of the forces in your y is equal to 0. By the way, I did something here without telling you why. This one is a roller here. So it's one force, but this one is a pin. It's supposed to have another joint here. Another force, right?
Sir, this is all most questions would be, right?
Yes.
Stated
So you
like
have
this.
one, yeah. So it's actually one would be, this is a pin joint right here. Oops. This is a pin, so it should have 2 forces there. I'm going so fast. This is a pin. This is a pin. Why is this thing?
Sir, so how would I know that?
Look.
Just by looking at it.
Look. Once it has a roller here, notice this is a roller, something it rests in here. This, you cannot see it good probably, but this is a circular thing here resting on the ground. Right? And this is a pin. This is something pinning through it here. So they are different.
No, but so you have one pin right there, so where the E there?
Where? No, this is a roller. It's a roller here. See, it's rolling. You cannot see the
No
joint.
man, look underneath it.
So, yes,
Most
it's
times,
a
that's what I
roll.
was
It's a
asking,
roll.
you know,
Sir,
most
It
times,
roll.
always
So the body can
one
move
side
in the
always
horizontal
roll on,
direction. So you will not
right.
have any force in the horizontal direction there. But this one is a pin. A pin is in here, so you're supposed to have two forces there. So this is also a AX. You get me? You get me, sir? You get me now?
yeah, man. Yes,
So
sir. Rub out
yes,
that, rub
you
out the,
will
rub out the lines we
always
have
have
underneath the
wherever you
MC.
have a roller. But guess what? You see, because you don't have any other forces up top, for this one it is not so crucial. When you have other forces up top on the frame, it becomes crucial because AX in our case it is the only force horizontal. So in that expression, your FX equal to 0. When you apply it, this principle, you're gonna get Fx is equal to 0. So that one going to drop out of the problem. And only, but for the y, it's different, right? So this one not too crucial for some frames, but for some frames where you have another force probably hanging off in the horizontal anywhere up here. Remember we did the last one we did in class, where it was pinned to the wall, and the one going in and one going out, it would be, you say it wouldn't be 0 in that case. All right. Once the frames are resting vertically, pinned to the ground, then it most time the AX is 0. All right. So let us continue on now. All right. So this is what we have, and we want to find two forces, AH and AB, right? So what you're going to do, and I want you to watch it carefully now. People doing free body diagram and we're not drawing free body diagram, right? So we're going to consider, let me be very clinical here now. You're going to consider joint A, all right? And now that you're considering joint A, right, you are going to draw the forces. We can leave out the AX because it is 0. So let's draw the joint. So the joint, you know, let's draw it clearly. I'm going to draw it right here. You can see it. So one force is going in. That one is 0. I probably can leave it out, but I draw it with us clarity. The next one is going to be leaving this point going up, and we're assuming that it is in tension. It can be in compression. There's also one coming into the joint, reaction, and there's one leaving it, we're assuming again, in tension, right? So this one now, all right, so this angle we know is 45. It don't look like 45, but it's 45. I draw it bad. Probably I could redo that one. All right. All right, so let's redraw that one again. Probably a little bit steeper, something more like that. All right, okay. Now, so this is 45 degrees. Now, this force will have two components, one in the vertical and one in the horizontal. While this one is, so we label them now. So this is A, and this is, so you could call this AH, of course, FAH, you can call that one, while you call this one F. This point is what now? B. So this place says it's going to be AB. Right? Why? Look, between here and why do I call it that? Is because up to this point is B, up to this point is A. So you must call it FAB. These are the forces that we're doing. I will leave out one down here we need to put in. The other one is going to be AY. I could leave out AX because AX is 0. Right? But I draw it for clarity. So nobody can say them don't know how to draw a joint. Because I see people drawing joint even in a project and they're not doing it properly. All right. So let's continue now. So here now you're just going to use your equilibrium equations, right? But before you do that, I'd recommend that you find your reactions. Always, I draw the joint. I actually went before. Let's take a moment and find some your AY and your AE because we haven't done that. Let us pause a little bit and step back. I'm going a little bit fast. Yeah. We're gonna pause. Let me just separate the line here. Maybe I should use a different color and to mix you up. Let's do it over here. All right. So we're gonna do some movement here over here, and let's use our regular color, black. All right. So you could take moment. We're gonna take moment. Wow. Take moment. Where are we gonna take moment now? We're gonna take moment at A. If you take moment at A now, let's just do it. And I want you to watch carefully. We're gonna take moment at A. Our objective is to find AY and AX. So we're gonna take moment. If you take moment at A, say sum of the moment at A equal to 0. That's the first statement. Right? Or you're right, take moment at A, but normally and you're gonna put anti-clockwise direction as positive. So I know exactly what you're doing. Right? So you convention that. So you're taking the anti-clockwise as positive. So let's proceed. So you put your hand right here. Remember, right at this point, and you know that all of those forces in that point are cancelled out, them gone. They are not acting in your moment equation. So let's start now. So the first force that we contend with is the 5. What is the distance from A for the 5 force? This one right here. What is it? What's the distance? So it's going to be 5. The 5 force is
Yes.
going to be 8. Yeah, so this one will be coming that way. So it is going to be 5 times 8, because 4 plus 4 is 8. So it's 5 times 8. That's it. Right? And it is minus, because it's going into the clockwise, right? Opposite to our convention. The next one is going to be the 3. What's the distance from A? It's also going to be minus 3 times. So it's going to be 4 plus 4 plus 4. So you get 12. All right. And the last one would be it going positive up. So it's EY times what? Times 16. Because it's 4 times 4. 4, 4, 4, 4. So it's 16. That's the distance. And it's perpendicular distance. 4 times equals to 0. So that gives us what now? 5/8 is 40. So it's minus 40 minus 36 plus EY times 16 equals to 0. So there, so EY times 16 is going to be equals to, you're going to take the minus, add them and carry them over. So it's going to be 76 divided. So now your transpose, so EY is going to be 76 divided by 16. How much is that?
4.75.
Oh, what happened to my calculator? It's not coming on. Is the battery gone? Wait. Uh-oh. Guys, I can't believe it. My calculator look like say it tell me goodbye. Uh-oh. Seriously? I must be mistaken. No, it did. Gone, guys.
So see if you can use the reset button.
No. Oh, come on here now. I was wondering what's wrong with it. All right, it's back. All right. It means that maybe the battery died. All right. Anyways. All right. So this is how much you say that was again? 76 divided by 16.
So 4.75.
Right. I have another one, a computer. Well, I tend not to use it because this is what? Kilonewtons? This is kilonewtons. Yeah. And this is right. So the next one you need to find, you need what now? You need AY. So AY, you can just use any one of the sum of X or sum of the Y. We can sum of the Y because that's the vertical, that's what we need to use. So we're gonna just say, so the sum of the forces in the Y, let's sum all the forces in the Y now, guys. Let's write it down before I move it up. So equal to 0. So what are they? So you have, so it's going to be AY positive minus 5 minus 3, because those are coming down. AY is positive going up, minus 3 plus EY equals to 0. Right? So therefore, this is AY minus, this is what? 8 plus EY equals 0. Now, what do we have? We have EY already, so we need AY. So AY transpose is going to be equals to, the 8 come over is positive, minus EY. So this should give us our answer, say to be 8 minus bracket, put in the 4.76. So that answer now equals the difference between that. What's that difference now? 3.25, is that correct? Positive?
Yes, sir.
Kilonewtons. All right. So that is your, so we have found now EY and AY. And you need those critically in order to work with, eh? You cannot work with those without it. So therefore this is going to be 3.25 kilonewtons. All right. So that's that. Now we can go ahead now and start to solve for our joint. All right, because we needed the reaction force in order to work it out. All right. So let us start now. Which one are we gonna find first? I must tell you, it is advantageous sometimes to go with the y first. We can do our equilibrium equation, but it is advantageous at times to use your y first. So some of the forces in the y, let's look at that one first. But first we need to observe what are our components in our y direction. In the y direction, you have a component here which is FAH is going to be equals to a sine 45. You agree? In the vertical. And then the one horizontal is going to be FAH cos 45. Do you agree? So it will have a component horizontal and vertical. All right. So let us go with the y. The one in the y is, and it's, so look for all of the forces going up. First one is going to be FAH sine 45. That's the first one, right? Because the component of of AH in the vertical, that is one. And then the other one is the vertical force, which is AY. So AY is equal to 0. And so from that, you can solve it because AH, we don't know, sine 45 minus AY is 3.25 equals 0. So you can, so now you transpose our FA. So this is going to be equal FAH. Remember, it's lower subscript. I'm not writing it too well, I realize. Times sine 45 equals to 3.25. And you transpose that now, and you're gonna get FAH, this is A, equals to 3.25 divided by sine 45, which is really 3.25 divided by 0.707. How much is that?
Sure, 4.59.
There's positive 4.55 kilonewtons. So it's the same,
Yes, no,
therefore,
5.9.
5.9, you said?
Yeah, 9.
Oh, so that means it is tension. Well, let's check that again. Let's see. Did we write that correctly? Why did we have it as minus here? It's not minus. The AY is not minus. The AY is supposed to be plus. You didn't realize that, guys? Oh, Lord. It's plus, man. It's positive. It's good. Both of them are going in the same direction, positive. Yeah, so this is minus. This is really in compression. So yeah, so it's really in compression. And this is 9, so it is minus. So it's a compressive force. So it means that it's actually going in the joint rather than coming out. All right. So that is that value. Yeah, because look, this one is going up vertically, and this one is also going up, AY going up. So they're going both places, they must be both positive. All right. I don't know why I was writing minus. Anyway, next one, we want to find AY. So we're gonna have to go to the horizontal components now. So let's make that a little bit smaller. that you can see it. So the horizontal component now, let's consider that one. I hope you can see it and make it a little bit smaller. Just look at the joint up here. I hope it's not too crowded. All right. So we're going to consider, let me use a different color so that, which one I could use? Blue. So the sum of the forces in the x equals to 0. So let's do that one. So we're gonna sum everything. All right, ax is really 0. If you put it there, it's not have any but you can put it in the positive. We go in the positive direction. All right, it's 0 though. The component of ah is going to be plus f ah cos 45. And then now we have which other forces there horizontal. So we have highlighted two forces that we are contending with. Everybody see them that are horizontal. So one is here and this one. And plus this one. So it's two of them, but one is 0. All right. Everybody following? So
Yes, sir.
this was F A B equals 0. Aisha, are you following? Are you going to sleep?
Sir, I'm not sleeping.
But so why you not answer me? All right. All right, good. So therefore this is 0. So it's really not in a problem. That's 0. So therefore we just continue with these two. Now we have a value for 4, 5, for the AH, which is minus 4.59 cos 45 plus FAB. So you know FAB is going to be what? It's going to be tension or compression. Who can guess? And what is the value? So the value is now going to be FAB, and it equals, now you're going to carry it over. So this is positive, so you carry over that other one, become positive. So it's 4.59 cos 45. And you can tell me the answer now. Cos 45, what is that? Please, guys. What is that?
So 3.25.
It's positive 3.25 again. Kilonewton. So it's the same value there, and it is in what? Tension. While this one is this is compressive force. This is compression. Right? Once it's minus is compression. So we have gone ahead and we found just two. You could be asked to find ED down here, and you take that joint also. So I've demonstrated to you to find AH and AB. And you see how I've drawn my joints them clearly? That is what I want to see. If you don't put AY in the joint, you don't finish draw the joint, man. And you don't label it, you don't finish joint neither. And you must find the angle. So all the forces, we identify them. All right. Now, the problem, and that is method of joint, right? So I demonstrate finding 2. You could also ask to find DE. But let's go with method of section now, no? Because the time is going on. So let us clearly do method of section quickly. Method of section now, it says you are to cut the beam across, the frame across. So what I'm going to do, I'm going to copy it, I'm going to take it down, and I'm going to take a fresh page. I don't want to confuse you, right? No time is getting late. I'm going to take it a fresh page, and we're going to jump down here. We can come up for anything we need. All right. All right, so this is it. You see how big and nice and bold. We carry down some of the little writing that I have. I can erase them, but that's not important. All right, when it says you are to do method of section, you are just to draw the section that is important to you. You are not expected to draw the rest of the figure. Guys, you don't need to. All right, so you can decide. In a problem like this, you could say, which side should I draw? Should I draw the left side or draw the right side? Which side would you draw? Question I'm asking now, quickly. Which side would you draw, guys? Would you draw the left or the right side?
The right side, sir?
I would draw the right side because the right side seems smaller, right? The only thing is that I don't have some of the forces over there. But nonetheless, let's just draw it. All right, so you go ahead and you draw it. Let us see if we can draw it quickly. All right, so we can draw down here. Just a section. Yeah, so you draw a line down there. And you could draw another one here, probably. Yeah, and let's see, something like that. All right. And all right. Now, okay. I will have to erase a part of this line. Only if I can do that. All right, everything will go. Oh, nice. This one don't, everything don't go. All right, nice. So then now we need to draw the other section of it now. All right. Over here, you have to be very careful. You see where it cut? Beyond where it cut, you must draw it as a broken line. All right. My only thing is that the angle that I'm drawing now. So this is solid. All right. So you have to be mindful where your cutting plane line stop. All right. So everything beyond these points are broken. Broken. Right. Okay. You can typically use. We have some forces to put in. Right? So I'm making sure that I draw it. So this force must be in. And this force must be in also. We have this value. No, this is the wrong direction for that one. You have to be careful, guys. Make sure you put them in the right way because you're going to get the problem wrong. Right? Let's go again. So, oh Lord. It's not on the right thing. All right. Let's highlight him now. All right. So we have those. All right. Now, one of the things I need to point out to you, yeah. So this one, the arrow head, you can put the arrow head there. That's an arrow, right? So the arrow head is that way, and the arrow head are there, right? It means that those are the directions. All right. Now that we have done that, now let us label our thing quickly. All right, we already have some angles here. We had work out and know that this is 4. Let's define a different color. This is 4. This is 4. This is EY. That looks, wow, that don't look good at all. That is EY. This is 3. Now we can use these points here. This is C, and we can use G. This is F, and this is D, right? We may need this angle inside here, horizontal line here. We may need that one. We'll work out the angle for it already. Up top, it was 22 something. Right? The same thing. If this one is that angle, this one over here will be the same angle. Right? All right. What else did we know? We know that this is also 45 angle. You remember that? Because this is 4 and 4. This is 4 and this is 4. So right? So this is 4 here and that is 4. So it's 45. And this is 45. All right. So we have those. This up here is going to be 45 underneath here. Also. Right angle triangle there. Right angle triangle here. So you map them, you can see them. All right. So we can use point G. We can use point C. Right? Those are typical points that are important to us. All right. Now, we made some assumption where I put the forces. They may be wrong. Meaning that they might be in tension rather than in compression. We put some of them in tension. All right. I made some assumption. All right. Nonetheless. So we have this one here is, what was his value again? EY is what? We have his value. So it's important to us. Wow. That means that, hold on. Means that we have skipped 2 pages. All right. I'll get rid of that. So this is EY was what again? EY was 4.76. 4.76. Let's write that. Yeah. 4.76 kilonewtons for this value here. All right. So we have all of that. So the forces that we need to find here, we say we need to find what now? We call it, says, we're gonna just call it FG. You know why I'm calling FG? Is too much F. We're gonna confuse you. And this is going to call this FC or CF. Whatever you want to call it. Could call it CF. Just a labeling. Just a labeling. Right? Not necessarily following the number. Just a labeling. Alright? So we need to find this one coming in that joint. And we also need to find if you want to call it DC, maybe right way is to call that DC. And this really should have been calling FC, whatever. Normally we label them the direction in which the force is going. I think that's a standard thing. Yeah, over the years I used to do that. I just call it FC, standard. All right, and this is going from F to G, so I can call that FG. All right. All right. So let's see if we can get these correct now. All right. And I didn't work them out before, so we're just gonna roll with it. Okay. Firstly, we want to find the forces. Which one is it? You think that is easy to find? So we have this one. We could take moment, and the moment we take could actually help us. So if we take moment at C, so we take moment at C, we can try and find FG. So let's try that. So you're gonna take moment. Where are we taking moment now? At C. So it's sum of the moment at C. Taking anticlockwise as positive equal to 0. Let's use a different writer. That's too loud. All right. Yeah, it's too loud. So let's go now. Let's see if we can identify them. We are taking moment right here, right, at C. That means that FC gone, DC gone, right? And we only have 3K and the EY, and we have this one up here. Okay. Now, the question I want to ask you, we're going to have to look for components of this force here. What was that angle subtended at the top here? We need to find that angle. We found it already. What is its value? We had to work it out. It is 26 point. We're just going to round it off to 26.6. All right, 26.6. So this value is 26.6. All right. So it has component. You agree that it has component in two directions here, right? So it has a component there, and it has a component here. You agree? Right? Okay. Now, the component for up in the vertical, I think it's going to be running through C. So we have to be careful about one. I think we're going to go for the horizontal forces first. So we're going to take moment and we look for the horizontal component. The horizontal component here is going to be F, G, and the angle is what? Cos 26.6. But look, it's going in the negative direction. It's pointing that way. We're going to see where we go with that. So we have that component. So it's a component of the forces you're going to work with. You cannot work with the force itself because you will not maybe able to determine its perpendicular distance from F. So all of the forces from F, now the component that is vertical is running straight through here. So it will have a perpendicular distance from C. But it will, but the horizontal component of this guy here is of relevance to us. What's this distance here? It's 4. This horizontal component here coming here. Everybody following? So the distance that is relevant to us, who is not following? Talk to me. This distance here is what? 4. This distance up here is 2.
Why, sir, I'm not lying. I get a little distracted a while ago. Yeah, the method of sections, I don't know, right?
Yes.
Are you taking moments? Well, are you taking moments at C?
Yes, so I'm gonna do it yet, you know, me just line it up to show you what is happening.
Oh, yeah, line it up.
Yeah,
okay,
me not do
so
it
all
yet.
I do so far,
all I do so far is just
I
to
draw
identify
the free body diagram.
Yes. And look.
And where you identify?
You see this force here? We're gonna try and find this one first. This one here.
G?
Why?
FG?
Because look, you see around here, this one is not acting. If we're going to take moment at C, then mean FC and DC is not in the problem. So the only force that is important to us is FG.
Sir, you're blind me, boy.
Huh? Well, what? Too bright?
Yes, man.
Lord.
Oh, so you choose C because if you pick C, you have you eliminate um
FC
you
and
eliminate
DC.
FC and CD.
Yes. Yes, that gone. So only thing you're left with, but guess what? In order to identify the perpendicular of this force here, you have to look carefully because you want to, is a component of the force you have to work with. So there's a component here, see it here, in the horizontal, and there's one in the vertical. The one in the vertical, look, it's running straight through here, to this point here. So it's not important to us. It's the horizontal one is going to be important to us. So remember, so I'm acting from, I'm considering that they're acting from F in my instances. Based on how I have my thing, I'm considering that them acting from F in that direction. Do you understand me now? It makes sense to you? I am considering that they're acting. Yes, what I'm saying that the component is acting through here. This where I put the
The
arrow
X component.
the
Yeah.
X component. Yeah. So I'm saying that it is acting there, but the one in the vertical is gonna be running through. Look, G and
It's
C
not
are in line.
perpendicular to C, so you're
Yeah,
not go.
they're in line. So then we say the vertical component, I'm not gonna consider that one. I'm gonna consider the horizontal component. Anyway, I'm gonna take moment now. So I'm gonna take moment at C, and I'm looking for all of the forces that will be active. So now let us do it. So all right, to make things easy on everybody else, I'm gonna work with these two forces down here first. The EY and the 3 down here. Let's do this one first and then we'll come to the next one. So the first one, what's the distance from C to D? It's 4. But remember I said it's 4 and this is 4 also. Everybody remember that? That distance is 4. That distance is
Yes, sir.
all right. So look now. We're gonna start with the 3. So it is, are we using the convention anti-clockwise is positive. So let's go. So the 3 now, is it going to be positive or negative? Which direction is it going to go? It'll be coming this way. So it's going to be minus. And the distance is 4. Agree with that? Who don't see that one? So moving from this axis here, the first force we contain is a 3 coming this way. So it's coming into the clockwise direction. So it's going to be minus. Right? And the distance from C is 4. The perpendicular is right here. And the next one, the perpendicular is going to be there. So the next one now is going to also be, is going to be what? Plus, because it's going up. So, but the distance from C is what? 8. So it's EY times 8, right? But we have EY value. Anyway, the next force that we're going to contend is a component of FG, which is FG cos 26.6. See it up top there? As I wrote up here, see it up here? So it is right here. It is acting right here. FG cos 26.6. Right there. All right? That looks like you can't even read that. Let me move it out. Because it's small. I didn't want to close up the diagram. So that's where it's acting from. All right? So that is that component. It's really here. FG cos 26.6. All right? So that component now, acting from C, it is going to turn the body into a this way, counterclockwise. So that is going to be positive also. So I have FG cos 26.6. What's the perpendicular distance now from C? What's the perpendicular distance from C? Isn't it 4? So it's coming
4.
this way. It's coming that way. And its distance from C is this distance up to it. All right? So we consider that remember, it's essentially is here, so it's acting from, So it's here, see it here, see the 4 here, and it coming this way. So it is 4 times 4 equal to 0. Right? Let's look to see if the other one is acting there. If the other one is acting here, let me see if it have a moment. Yeah, you know, so it's actually the vertical one is actually over here now. It is really FG sine 26.6. Let's see if it where it's acting from. So it is if it's acting from here, not from G up here. Yes, it's acting from here. So would it have a moment? Let's look carefully. It would probably have a moment, you know. Yeah, because it's acting up there. So we're gonna put it in. What is distance though from C? Its distance from C is 4. Look good. Its distance from C is 4. Do you agree? So it's acting here.
Sir, where?
See it up here. See it up here. I just draw it up a while ago. So that force. So two forces are acting. Two components of this is not acting from the tip of G. It actually from the tip of F it's acting. Guys coming from FG. So there's two components. One is going up. Let me clean up the drawing. One is going up and one is going down. So one is going here. Are you seeing them? So one is here. We just did this one a while ago. Here's another one going up. Component for this force. So the component for this force is a sine though. Is a sine, this one. FG sine 26. If it's gonna go that way from C, its perpendicular distance is going to be 4. See it here? See the 4 down here? It is acting this way, and its perpendicular distance is this distance here. Right? So it's operating around here, but its effect is from here. Right? So it's going to come through. So we're gonna have to put that in the problem. Can't leave that one out. So it's going to be FG sine 26.6 plus 0. Right? Okay. So
Sir, so it's positive or negative?
Okay, good. We didn't, and what is this perpendicular distance? It's 4. 4 is supposed to be. Let me look see if it's positive or negative. It look like it's positive because it's going up and turning the body. So it is also positive. You don't see that?
Yeah.
Look, it's going to be
Right.
coming through here. Kind of hard to see it. It's coming up here. And it's going to tend to want to turn the body. And see him around here, man? Yeah. You're going to want to turn the body same direction. Are you not seeing the perpendicular? Is that the problem? Are you seeing the perpendicular? It's almost like it's acting through the tree, you know. So look, it's like it's acting through here. You got me?
Okay.
Yeah, it's like it's acting through here. So it's going to have a perpendicular coming from C. Yeah, so I'm putting it in. Right? So what's this value here now will be what? Minus 12 plus, this was what? 4.76 times 8. Plus FG cos 26.6 plus FG sine 26.6. Right, let's check that value, check them. This is time 4, and this one is time 4 equals 0. What are we saying these values here work out to be? Are we getting 1? We're just getting FG. So they're essentially sine, cos, and what was those? We're just trying to sine off it. You're gonna get the same 26.5, right? And then the cos of it, right? So you're going to just get F. So F, and they are positive, right? We are seeing both of them are positive. So we're getting minus 12, plus, what is that now? 4.76 times 6. Hope I haven't lost you. This is 38.08. These two are just going, if you factor out FG, and you'll have just what? Cos 26.6 times 4, or factor 4, 4. Look out the 4. It's easier that way for you to see it. We're just adding them, just algebra. And take out the F, this is time 4 too. See there? Time 4, time 4. I just miswrite, I wrote it bad down here. So it's written bad right here. It's a really time 4 here. Plus. Right? So plus sine 26.6. Right? And therefore that equals to 0. So that will give you 1. So here we are saying that it is minus 12 plus 38.08 plus 4 FG. Because this is going to give you 1. You can check that. It's not going to give you 1. What is cos 26? 26.6, 26 cos, go ahead, cos 26.6. Give me 0.894 plus what? Sine 26.6. Give me 4 point, let me just check what this value, 0.44. It actually give me a different value. 46, sorry. 2. Right? It's not 1. So what is work out to be now? We're gonna work out the first part. That is gonna give me 26.08 plus 4FG. And when you and in the bracket here, what that bracket gives you now? Add those two together, you're gonna get 0.894. We both got them as positive, so it is going to be 1.340, right? Equal to 0. What this work out to be now? So it's 26.08 plus 4 times that. We're getting what is this now? 5.36 FG. All right. I don't want to burn you out too much, because I know I have exam tomorrow and I have to get up and be fresh. All right. So we're not gonna go too far. So this one we transpose this one. What we're getting here now? We're getting FG equals to minus 26.08 divided by 5.36. What am I getting there? Divided by 5.36. I am getting here minus 4.865. Right? So that is we're saying that that one is compressive. It's actually going in the joint. This is what kilonewton. That's what it is saying. So they're saying rather than we carrying it out the joint, it's actually coming in the joint. That is what it is actually saying to me. All right. We are going to find the other two. We can use some of the forces, see if those will work for us. All right. Which other ones we have to find? We have the first one. All right. If we were to we want to take forces somewhere else now to see if we can find them quickly. All right, we're going to take moment at F and find DC. Let's try that one. So we can check them now. All right. So we're going to take moment now. I'm going to take back this diagram here. I'm going to clean it up a little bit. And we're going to do the next one. Let's clean it up. It's a little bit messy. Let's get it a little bit. Oh, that one. Wow, it's too big. All right. So yeah. Let's clean up this stuff. All right. All right. But I don't want to be drawing over anything. All right. You can always label that. All right. So we're gonna take a different joint. I'm gonna use the same figure. All right. So let us. I'm gonna remove this stuff. We're gonna redo it again. So this is a giant now. Same one. Let's place him somewhere down here. Oh, we want more space. Do we? All right. So I look like I lost one and now I'm gone permanently. Are you guys there still?
So we're not gone with there. I try to figure it out too.
All right, hold
Sir,
on.
what forgot, sir?
Okay. What's up? Now here no sound gone there than me. All right. Now, all right. So here now, look, let me tell you clearly again. We have, I am saying that we're gonna take moment now at F. Where's F? Let me put him back F. F is right here. Now so this was what? This was C. So this is FC. Right? So we're going to take moment at F. So we're gonna say take moment at F, and so you would simply just say sum of moment at F equal to 0. So let's see how this one works out. If you take moment at F, which forces are gonna drop out? FG gone, FC gone, so only DC. This one down here is relevant to us. So let's highlight it. Let me highlight it. So this one here. This one here is broken line here. This one is still active. That's the only one that is still active. Maybe you guys don't see it. Let me put a different color. This one is active. This one right here. Only. Right? If you take moment here, I should have taken out this one. It wasn't needed here. It's just a component. It wasn't needed. This one in black, it wasn't needed. It's just a component of FG. But all of that are gone. So FC gone, FG would be not in the frame. So the only force that I'm contending with down here is DC. DC, the 3 kilonewton, and EY are the only forces in the problem. So we're gonna take moment now. We know the distance already. Let's look for the distance and take moment at F. So let's look carefully now. All right, so we're taking moment at F. The first one, what's the perpendicular distance for the 3 kilo from F? For the 3 kilo, does it has a perpendicular distance from F? Yes or no?
Number 4, sir.
The 3 kilonewton, does it has a perpendicular distance from F? This one here. No, it is also gone because it's coming through.
Oh, because you run through it.
Yes.
Okay.
Right. So it run through F, so it is also out of the problem. So the only one that is relevant to us is this guy here, the EY. So EY, only two forces that we have there are relevant to us. So okay, we don't even have to take moment, but we can take moment. We could even use some of the well, we're taking moment now. All right, let's take moment. So we take moment with this one here. This only has a component in the horizontal, so it is easy. And the distance from F is 4 for DC. But which direction is it going? It is going into the clockwise. So it's minus. So it's DC. Right? If you want to write FDC, find with me. FDC times 4. All right. And the next one now would be this one coming up here. See here? The same one acting that way. What is distance from it? See there? It is going to be, see there? That is EY. The distance from F is going to be what? What's the perpendicular distance? Still 4. So it is going to be, but that one is positive. So it's going to be EY times 4 equal to 0. So you see what the answer is though. You should be able to tell me what is the answer. What is the answer? What is the answer there? So from that, EY 4 EY is equals to 4 FDC. So the 4 cancel. So EY is equal to FDC. So it's the same value, 4.76. So you see that EY is equal to DC, same value. So we are saying that FDC is equals to 4.76 kilonewtons. Right? So that's one thing that we know from it. So only one force is left. One is left. I'm going to say, all right. Let's take the sum of the vertical forces to see if we can find that one. I'm looking to see what's the easiest way to find it. Or we go horizontal. Let's check it. All right, so we're gonna go for the vertical forces and see if we can find the sum of vertical forces. Let's see if we can find it. So we're gonna sum Fy equal to 0 and look for all the vertical forces that we need to find in the frame. So we know that we have one going up here. All right, otherwise one is coming up here, which we had worked out to be what? Fg sine 26.6. We know we have one going up in the vertical. We also know that this one coming down, Fc, will have a component in the vertical also, and one in the horizontal. All right. So we work, the one in the vertical for this one is going to be minus, right? So let's write them down. So one is Fg sine 26.6 for this force. So for Fg, that component is positive. But what about Fc? Fc component will have a negative and a positive component. Is it so? Let me see. It will have one coming down here, or it will have two negative components. The x is negative and the y is negative. But we're concentrating on the one, but the y. So the y is negative, so it's minus Fc, and it is what? It is cos 45. Do you agree that it's cos 45? Look, there's a 45 angle right here, and it is coming down. What other vertical forces we have contend with, guys? We have the 3 coming down, which is 3 plus 4.76 equal to 0. What unknowns we have now? Only one. Do you agree? Only Fc we don't know. We have worked out a value for Fg, which I will want to double check and rework that value, but I'm going to use it nonetheless. I would suggest that we rework Fg to double check that value, right? To make sure that it's correct. But I'm going to work with the value now. The value that we got for it was minus 4.865. Where, let me see, minus 4.5, right? So we actually, so the value we have was 4. Hold on, I can't see it. So it's 4.865, right? Sine. This one is too loud. Can you see it? Is hurting your eyes? You can work with the blue, is all right?
Yes, sir.
Yes,
Well,
sir.
for me, yeah.
Fine. All right. This one down here work out to be what? 1 point plus 1. The difference between 3 and 4.75 is 1.76. Am I correct there? Equal to 0. All right. What this work out to be now? All right. Let me write to the block. Kind of hurting my eye now. What that work out to be? The first one. Minus 4.865. Am I using the correct value for Fg? Yeah. 865 times sine 26.6. So I'm getting minus 2.178. Everybody concur? Minus F. This is going to be 0.7071 FC plus 1.76 equals 0. So our FC equal to 0. Let's just quickly work this one out. We're going to just take FC over to one side. So it's going to be 0.7071 FC, which is going to be equal. You add the 2 here. What's the difference between minus and a plus 1.76? Work out the value for 2.178 and plus 1.76. You're gonna again end up to get minus 0.418. So FC is equal to your different divide 0.7071 by that. And I'm getting here, tell me if you get the same thing. Check that value again for me, please. I'm getting 0.59. Minus. Can you double check that value for me? Is that correct? Anybody concur? 0.14.
Yes, sir. Yes, sir.
Yeah, I'm getting that value. You will have to double check these values here, guys. This look like a minus. You double check those values in the workout. But the principle behind it is what? So we have gone ahead and we have used method of section. All right. Method of section is a little bit more, you have to be a little bit more, what should I say, technical with it. So I recommend, I'm gonna try and find the standard solution and send to you guys. There possibly a standard solution for it in terms of this problem. I'm gonna try and find it. But anyhow, this is one way to do it. It's a little bit of jigsaw to get to it. So you can use moments at these points. You see at F and C, you can use moments. Remember, you can, these points here, you can still use them. Don't believe that you cannot because you cut it the frame. Remember, your cutting line, you come across the thing. You cut it. You cut it across here. Right? But across here, these are dotted lines. Dotted, dotted, dotted. Dotted, dotted. These are solid coming to the cut line. Solid come. Solid come to that. And then after it is dotted line. So you can therefore use G. You can use C. You can use any point, right? You can't use anything else on the left, but you can use G and C to take moment, right? So please remember that you can use those points to take moments, always, right? So those are the points. I don't want the block here to think the block one is part of it. The block is not a part, that is just sketch line to assist you to see it. So those are points. Yeah, I'm finished.
Question, section B. 3 questions. Moments. This what we just do a while ago. The one with inertia.
Yes.
And the one that we did yesterday.
Okay. Yes. All right. There's something that I wanted you to remember to look over. Okay. Tomorrow morning, make sure you look over these. You may get something in your multiple choice about these. Remember this?
Sir.
These, you're getting multiple choice. You remember that? These, you're getting something looking like that. And
just like ask about the friction, something there, you know.
That me I said me not
yes,
study
so you must make sure you look over this in multiple. Yeah, man, that's why I thought. That's why I went through it. Remember, one of the last class we stopped and went through it. So go back to the slide. You have it, the friction slide. Go back to it and make sure you understand how to use this formula here. That the net force is always going to be the difference between the pulling force and the frictional.
The frictional force.
Yes. Remember, you must know this is kinetic friction and you have static friction.
All right, so sir,
Right, them.
question. All of these formulas will be on the back,
right.
right? But if you don't
What?
understand how to use it, the formulas will they be on the back for the friction?
Some formulas will be here, not all. All right.
Murder boy.
Let me tell you what you must remember to use for this. So looking through these type of problem, these are basic problems. You must remember this. See here, it all work out, you know. Let's go back to this. See here, net force is equals to net force will be work. This is frictional one, and you have the static one. Right? Go back to these. See them there? Basic. Just read back to these that if you get any multiple choice like these, you're able to work them. These are just basic, just a basic thing. You're not any no detailed questions, you know, just small question for you to do little workout.
Sir, how much multiple choice?
You're gonna get 15 multiple choice, which values 20.
So 15
You're gonna get a question that you're gonna answer as multiple choice. You're gonna get a solid question, a kinematic question that you're going to work out as multiple choice. Right?
Okay.
And some of the answers will value not 1 but 2 marks and so forth. You will see the marks attributed at this exam. So you're gonna get 15 multiple choice, but it's a structured question which you're gonna answer in a multiple choice fashion.
Okay.
That you're gonna get a kinematics question that you're going to work out the parts and you look for the answer and select them in a multiple choice. Right? But the rest, so this exam is predominantly a more structured paper. Don't expect a lot of multiple choice. All right. So you're gonna get 15 in all. So that means you're gonna get, look at it, you're gonna get 15 all question with value 20. So probably 20 solid multiple choice, and then the next 10 is a solid question which you're gonna answer. You're gonna get you're going to choose from. Right? And then after that, you're going to choose. I think you have a compulsory question again, solid question in vectors.
What do you call a question there? The vector question.
Yes, the
That's
same thing like what I
the
worked
compulsory one.
The same thing like what I worked last night.
Okay, so that's a compulsory.
And then you're going to get
choose between three.
You're gonna get a centroids, and you're going to get a trig. No, centroids. What right? You're gonna get a truss and a centroid.
So
you're gonna get a projectile.
Oh,
projectile. I think you're going to choose. But remember, you're going to choose between the projectile, the not the kinematics, the
centroid or the truss.
The centroid and the truss. You're gonna choose. So you're gonna choose either to do the truss and the projectile, or you're gonna get right. So you're going to choose. So you're gonna get 3 or 4 questions there to choose from. I think it's 3. If I remember,
I choose 2.
2, yeah. Because the paper is gonna be in all value about 80%. So it means every question is about 20 marks on each question.
Oh, yeah, you hear that?
You understand what I'm saying? So the multiple choice will value 20, the structure will value 20, and the other 2 questions is 20 each. So it's 18 all. You get it now? So all right, I'm going to release you guys now, so you can have your rest and your reading tomorrow. And if you have any question, you can text me. I'll try to see if I can send you another. When you see the video, you can look at the other Truss video that I have there. It's a little bit more complex, but nonetheless, yeah. Go ahead.
Sir, you never put some things on the. You never put some quiz for try and
Hear me. After the exam, we can discuss that. Concentrate on the exam. Afterwards, there are 1 and 2 persons who have very poor midterm grade. I can try and open a midterm quiz for you after the exam, and you try it while I mark papers, and hopefully when you score better, and I'll just substitute those grades when I'm submitting. All right? Oh, that's all.
Thank you.
So that same one that I put there on the start, steam off, and I just lock it down same time. All right, the same one I'll use something like that. Two of them. I'll give you one for the quiz. So I'll give you maybe two, either one or two quiz. One for the to help for your quiz question and one for your midterm. The midterm probably is a one to concentrate because is much more marks for the midterm. I think it's all about 20%.
Okay.
All right.
Okay.
All right, guys. Have a good one. Get some rest, and then
Thank
get up
you.
and read and rest between because you don't want to go to exam tired because your brain not going to function well. Drink enough water, and make sure you go bathroom, empty your bladder. You guys' bladder are strong, and do well on the exam. All right. So, wish you the best.
Thank you, sir.
All right,
Text
sir.
me if you have any question. All right. I'm marking paper, but I'll make myself available. All right. So let's go through you can make the videos play and listen to them. Especially the Truss question where I was very detailed. It might be a little bit more complex, but it will give you the principle. All right. All right, guys. Have a good one.
All right.
Yeah. We'll go.